This video discusses experimental error and how we use the term error in this class. Now, scientifically, error does not mean a mistake. It's closer to some uncertainty, so we're uncertain of what the true value is. And no matter how well we measure it, we will never know exactly what the right measurement is. You should never tell me that you performed an experiment entirely correctly, therefore you had zero error. In an upper level course, you'd be expected to estimate the range of error. So instead of giving an absolute defined number, you would give plus or minus some percentage. Now, error comes in a couple different flavors. The first is random error. Random error is going to change with each measurement. So sometimes the uncertainty will be higher, sometimes it'll be lower. What that does, it reduces the precision of an experiment. So the more random error you have, the harder it is to get numbers that are close to each other, the same, again and again and again. And the effect of random error can be reduced by multiple trials, so that's a good thing. The more trials we take, the better our average can be, the more we can reduce the random error. So, to take a look at what random error would look like in an experiment, I have LoggerPro hooked up, and I have a mass sitting on a force plate sensor right now, and you can see that the force is jumping around a little bit. And that's due to random error. If you were making a measurement right now, you'd have to pick one of these numbers that's scrolling by. How would you know which one to pick? Well, you'd take a look at them, and you'd come up with a good average, some estimate. Then you'd take your weight off, you'd put it down again, and you'd repeat that a couple times and come up with a good average. If we take a look at a graph, now this graph shows mass versus weight, and it has a lot of random error. So that random error, you can tell how much it is by how far the blue dots are offset from the trend line. So we have a nice trend, we can easily identify it, but we have a lot of random error because the points are not lined up very close to the trend line. If I superimpose a better set of measurements over it, you'll see that we get a set that's almost all on the trend line. If we zoom in, there'd be a little bit of offset, but these are much, much closer. If I take a look at what that does to the equation of the line, the blue ones are on top, the red ones are on bottom, the red's 9.8. You're going to get very familiar with that 9.8 number, and that's going to be the more correct of the two. When we talk about systematic error is error due to incorrectly calibrated or misused equipment. So what that means is if I have a scale and I tear it, that's calibrating it. If I forget to tear it, it's not calibrated, it's incorrectly calibrated. Or a worn meter stick, if my meter stick's not a meter, it's not calibrated. If I incorrectly set my sensors, so if I have a sensor that's reading from 0 to 10, but it's set to read from 0 to 50, that will send the wrong signal to the computer, and then I will get some systematic error in my measurements. And systematic error reduces the accuracy of the experiment. So if we think of the dartboard and accuracy and precision, accuracy is how close to the bullseye we're landing. So with systematic error, what it does is it offsets the trend line. All the points get shifted upward whenever we have systematic error, or shifted downward. And you can see that here we have two slopes that are exactly the same, but the one with more systematic error, the red one, has a y-intercept of 2.5. Well, this would be weird. If I had a mass, so x is mass, of 0, you'd expect it to have a weight of 0. But for the red one, that mass that's 0 grams would be 2.5 newtons. That'd be weird. So, our goal in this class, we want to eliminate large systematic errors by correctly using the equipment. We want to reduce random error as much as possible by using appropriate techniques, so taking an appropriate number of trials and then averaging it. And we want to identify our sources of error. People who are professional scientists, they will state, here's what the errors in this experiment are. And that's what we want you to aspire to be able to do. Okay, thank you.